we're going to take a look at our third method of solving a system of equations. So our goal is, I know how to solve a system of equations by the method of elimination. So we've looked at graphing, we've looked at substitution. Today we look at elimination. So it's just another method, and you'll understand once we go through the steps and do some examples why it's called elimination. So the steps are a little bit different with this one. We're going to start by making sure that the variables, the equal signs, and the numbers in the two equations are all lined up. And once you do that, you're going to number the equations. Now, we talked a little bit about numbering the equations in the other examples. It's very important in elimination that we number the equations. So the second step, multiply each equation by the number that will create the same coefficient in the variable of your choice. So the coefficient, remember, is the number that's in front of the variable. And this will make a little bit more sense once we do an example. So if this is confusing at all, just copy it down, and then we're going to talk more about the steps as we go through the examples. So if these changed coefficients are the same sign, we're going to subtract the two equations. And if the two coefficients are opposite signs, we will add the two equations. And then the part at the end here looks the same as what we did in the other ones. So solve for the variable, solve for the other variable, and then if you're asked to, you can check your answer with a written check, or you can check it on your own just to make sure you get the right answer. So let's take a look at example 1 here. So you can see that to start with, everything is lined up for us. The x's are lined up here. The y's are lined up here. And the constant terms, the numbers without variables, are lined up together on the other side of the equal sign. And the equal signs are lined up as well. We're going to number the equations, so we'll call that equation 1 and that equation 2. And then for step 2 here, it says multiply each equation by the number that will create the same coefficient in the variable of your choice. So we want to create the same number in front of the x's or the same number in front of the y's. In this first example, we've got the same number in front of the y's. There's a 3 in front of each y. So we don't need to worry about this step here. We can jump to step 3. And step 3 says, if the changed coefficients, so if the numbers that are the same there have signs that are the same, we're going to subtract. If they are the opposite signs, we're going to add. So you can see we've got a plus 3 and a minus 3y. So we are going to add these two equations. And you'll see why it's important to do that once we add them. So, and we just add them straight down. So 4x plus 2x gives us 6x. If I add 3y and negative 3y, I get 0. So I don't even have to write anything for that part. And then on the other side of the equal sign, I add 18 and minus 6, and I get 12. Now we're going to solve for the remaining variable. There's only an x there, so we had eliminated the y variable. So that's why it's called elimination. So our last step here, we're going to do 12 divided by 6. So we get x equals 2. Now we have to solve for the second variable. So to do that, we're going to sub x equals 2. And we can sub it into either one of the original equations there. So let's sub it into, equation 1 has all positive values, so let's sub it into 1. So equation 1 is going to be 4 times 2 plus 3y equals 18. 4 times 2 is going to give me 8, but I'm going to move that to the other side. So 18 minus 8 gives me 10. Then I have to divide that by 3. So my point of intersection in this case is 2, 10 over 3. So that's my solution there. Now I'm not going to do a formal check this time, but you need to be prepared for questions where they do ask you to check those. Okay? And they won't always be nice answers. Sometimes we're going to get a fraction like 10 over 3 there. We're not going to change it to a decimal. We'll just leave it as a fraction there because 10 over 3 would give us a repeating decimal. So we really don't want to change that to a decimal form. So now we've got the next equation here. So we need to line everything up to start with. You can see that things are a little bit mixed up here because the top equation starts with x and then y and then the constant term on the other side of equal sign. And the second equation starts with y. So the first thing I'm going to do is I'm just going to rearrange. I'll leave the first equation and then I'll rearrange the second equation so that the x's and the y's are lined up together. So that's going to be equation 1 and equation 2. Now, we don't have the same number in front of the x's. We don't have the same number in front of the y's. So I have to multiply one or both the equations by a number to try and create the same number in front of the x's and the y's. And the reason we can do that is that if we multiply every term in an equation by the same number, we really haven't changed the equation at all. It's still equal. So when I look at this, I can easily multiply equation 2 times 3, and that will create the same number here as I have up here. Okay? So if I do that step, so I have to multiply each thing in that equation by 3. So I'm going to do 3 times this, I'm going to do 3 times the y, and I'm going to do 3 times the negative 2. So I have to remember that I multiply each part by 3. So 3 times 2x is going to give me 6x. And 3 times y is going to give me 3y. And 3 times negative 2 is going to give me negative 6. So that's a new equation. So I'm going to call that equation 3. Now equation 1 from up above, I'm not changing at all. So I'm just going to rewrite it underneath equation 3. So that's equation 1. So now that I have the same number in front of the y's in both cases there, when I've got the same sign, I have to subtract the equations to eliminate the variable. So once I get that same number, I'm going to put a line underneath because I'm going to add or subtract here. In this case, I'm going to do equation 3 subtract equation 1. So 6x minus 5x is going to give me 1x. 3y subtract 3y is 0. And negative 6 subtract 20 is negative 26. So x equals negative 26. Then I need to sub that back into one of the original equations. I'm going to substitute into equation 2. So sub x equals negative 26 in 2. So when I do that, I'm going to get 2 times negative 26 plus y equals negative 2. So I'm going to get y equals negative 2. And then 2 times negative 26 is negative 52. when it goes to the other side, it's going to change to plus 52. So I'm going to end up with y equals 50. So for the point of intersection, the point is negative 26 and 50. Okay? So I'm going to leave that there. We'll do example C together tomorrow in class as a warm-up. And then we'll go from there. Okay? So we'll see you tomorrow in class.